All right, let's get into it. Today, we're digging into something that seems, well, pretty simple, but it's actually a total marvel of chemical engineering. We're talking about mud. And no, not the kind you find in your backyard after it rains. We're talking about the high-tech, super-engineered fluid that makes all of modern drilling possible. So, how does this special mud pull it off? Let's find out.
I mean, really think about that for a second. You are literally boring a hole miles deep through solid rock with all the incredible pressure and heat that comes with it. What is stopping the whole thing from just caving in, or all the junk you're drilling out from getting stuck? The answer, it turns out, isn't just about power. It's about a very, very smart kind of mud.
And this quote from our source material just nails it. The success or failure of a huge, multi-million-dollar drilling job can literally come down to getting the mud recipe just right. It is so much more than dirt and water. It is the lifeblood that keeps the entire operation alive and pumping.
So let's take a closer look at what this lifeblood actually is and, how it circulates right through the heart of the whole drilling operation.
Okay, so here's the official definition. The two words you really want to latch onto here are heavy and viscous. It has to be heavy enough to manage all that pressure deep underground, and it has to be viscous, thick enough to carry all those bits of crushed rock from the bottom all the way back up to the top. It's a suspension, a super carefully balanced engineered mixture.
This diagram is perfect for showing the mud's round trip. So it starts out in these big mud pits on the surface, then it gets pumped with incredible force down the middle of the hollow drill pipe, and it shoots out of these little nozzles right at the drill bit. From there, it does its job, picks up all the rock debris, and then flows back up to the surface through that space between the pipe and the wall of the hole, which, by the way, is called the annulus. It's just one big, continuous loop.
Okay, so what is this stuff actually made of? It's not just one thing, that's for sure. It's more like a complex recipe, and it's custom tailored for the exact rock formations and conditions of every single well.
Honestly, the best way to think about it is like a four-step recipe. First, you start with your liquid base. That's usually either water or oil. Next, you gotta add some stuff to give it weight. After that, you mix in something to get the thickness or the viscosity just right. And then, for the final touch, the secret ingredient, a whole bunch of special additives to fine-tune it for whatever the well throws at you.
And this is where the real chemistry magic happens. To make the mud heavier, engineers use these really dense minerals like barite. To make it thicker, they use special clays like bentonite, or even polymers. Is the mud getting too acidic? No problem, add some caustic soda. Are you losing fluid into the rock itself? Throw in some starch. See? Every single additive is like a specific tool for a specific problem happening thousands of feet below the ground.
So just like a carpenter wouldn't use the same saw for every cut, drilling engineers can't just use one type of mud for every well. The biggest choice they make is that base fluid, water or oil, and that decision creates two totally different kinds of mud, each with its own set of strengths and weaknesses.
This table lays out the trade-offs perfectly. On one hand, you've got your water-based muds. They're cheaper, and they're generally a bit kinder to the environment. But, and this is a big but, they can sometimes react with certain types of rock, which can make the hole unstable. Then you have oil-based muds. They perform amazingly well, especially in super hot wells, and they're great lubricants. The downside? They cost more, and they come with a lot more environmental and safety headaches. So, to try and get the best of both worlds, engineers came up with a pretty clever solution: synthetic-based muds. These use a kind of synthetic oil as the base, which gives you all that high-end performance of an oil-based mud, but with way less toxicity and environmental risk.
Okay, so now we know what it is and what it's made of. But what does this lifeblood actually do down there? Well, it's not just one thing. This single fluid is a master multitasker, performing at least 8 crucial jobs, all at the same time. Let's run through them.
First and foremost, it's a conveyor belt. Its flow and its thickness are perfectly engineered to lift all of that crushed up rock from the very bottom of the hole and carry it all the way back to the surface for disposal. Getting that balance right is a really delicate act.
And while it's doing that, it's also working as a coolant. The friction from all that steel grinding against rock creates a ton of heat. The mud is constantly circulating to pull that heat away and lubricate the whole system, which is absolutely crucial for preventing a catastrophic failure. Now, this brings us to what is maybe its most important job of all: controlling pressure. You have a miles-long column of this heavy fluid, and its sheer weight creates this immense pressure at the bottom of the hole.
That pressure pushes back against the natural pressure inside the rocks, acting like a giant safety barrier to stop oil or gas from rushing up the well uncontrollably.
At the exact same time, it's holding the wellbore itself together. The mud actually deposits this thin, tough, waterproof layer on the walls of the hole. They call it a mud cake. It doesn't just stop the drilling fluid from leaking out, it basically seals and supports the hole, stopping it from collapsing in on itself.
The mud is also an active part of the machinery. I mean, it's being pumped with enormous force, right? That hydraulic power travels for miles down the hole, and it actually helps power the drill bit and keeps the bottom of the hole clean.
And get this, it even helps carry the load. It's just simple buoyancy. A drill string can weigh hundreds of tons, but when you submerge it in this super dense fluid, the fluid helps support all that weight. That takes a massive amount of strain off the rig up on the surface.
Finally, the mud is both an information superhighway and a really clever safety net. Geologists analyze the rock cuttings it brings to the surface to learn about the formations miles below. But what happens if you have to shut the pumps down for a while? This is where a property called thixotropy comes in, and it's brilliant. The mud is designed to instantly turn into a thick gel the moment it stops moving. This suspends all those heavy rock cuttings right where they are, preventing them from falling back down and jamming up the whole well. Then, as soon as you start the pumps again, it instantly turns back into a thin liquid and starts flowing. It is a truly incredible feat of engineering.
So, when you think about everything this stuff has to do, all at once, controlling insane pressures, cooling, cleaning, supporting, transmitting data, it's pretty clear this isn't just mud. It's a complex, dynamic, life-saving fluid. It really is the lifeblood of the whole operation. And it kind of makes you wonder, what other simple things around us are hiding some absolutely incredible science?